Hi guys, welcome back to another video. I am Nero from Cognicore AI, and today we're diving into something exciting, the newly released Qwen-Image text-to-image model. I'll also share a super fast download script to grab the models on RunPod, so stick with me. This is a 20 billion parameter MMDIT model, and it's packed with impressive features. Let's take a closer look at what it can do. First off, it offers superior text rendering. Think multi-line text in both English and Chinese. It also brings some standout image editing capabilities, which we'll explore. Now, let's check out the benchmarks. Qwen-Image absolutely dominates in text-to-image, image editing, and text rendering, leaving other models in the dust by a huge margin. Pretty wild, right? Let's move on to some image generation examples to see it in action. Here's one showcasing its Chinese text rendering and complex scene understanding. Another example, again with Chinese text, spot on. Now, this one's for English text rendering. Check it out. All the text from the prompt is perfect, and the prompt following is top-notch. Next, the complex English text example. Every word is accurate, and the adherence to the prompt is unmatched. Seriously impressive. We've got more to see. Take this bilingual text rendering example. It flawlessly handles both Chinese and English together, no mistakes at all. Then this poster design, amazing variety in fonts and styles, plus it nails text placement and semantics. It can even create PPTs, as you can see here. And check out these examples for different art styles. Pretty cool, huh? Now, let's shift to image editing examples. Qwen shines here too, handling style changes, adding or removing objects, extracting elements, object replacement, and maintaining character consistency like a champ. On their GitHub repo, they noted that the image editing model is coming soon, so for now, we're focused on the text-to-image version. Good news, ComfyUI has already added native support for it. Here we have the ComfyUI compatible model files and some images generated with the model in ComfyUI. The images look fantastic with spot-on text. This is the Comfy.org Hugging Face repo for the Qwen-Image model files. The main model is around 41 gigabytes, and it uses the Qwen 2.5 VL7B model as its text encoder, a refreshing switch from the usual T5 XXL. The VAE is the WAN 2.1 VAE, fine-tuned to handle images. Fun fact, both Qwen and WAN come from Alibaba. Alright, let's deploy a pod and start testing this in ComfyUI. I'll go with the L40 GPU since we need 48GB VRAM to run this at BF16 precision. I'll switch the template to PyTorch 2.4, add 80GB storage. Should be plenty for this, expose port 3001, and click Deployed. Now we'll wait for it to spin up. Once it's deployed, click Connect and access through port 8888. Let me adjust the terminal font size so it's easier to see. There, looks better now. I'll install ComfyUI using our script from the PyTorch 2.7 video. If you want to install ComfyUI with Python 3.12, PyTorch 2.7, and CUDA 12.8 using an automatic installer, check the video in the I button. Awesome. ComfyUI is up and running. Next, we need to download the Qwen-Image model files. I've got a super fast download script for you. Find it in the description, upload it to the Jupyter Labs workspace, open a new terminal, and run the command from the description. Watch this. It's downloading the main model first, showing the speeds, then grabbing the Qwen 2.5 VL7B text encoder and Qwen-Image VAE. All files are now downloaded and placed in the ComfyUI Models folder. Let's head to the ComfyUI Models folder. Here are all the downloaded files. Move the Qwen VL to the text encoder folder, the main model to the diffusion models folder, and the Qwen VAE to the VAE folder. Now, open ComfyUI through port 3001. For the workflow, I'll grab this one from the ComfyUI examples blog, drag the image into ComfyUI, and it loads the workflow. It's a pretty simple setup. Let's select our models in the loading nodes. We've got clip text and code nodes for positive and negative prompts, a case sampler, and a model sampling Oraflow node. Let's dig into the details. Checking the diffuser's code on the Qwen-Image GitHub repo, we see the supported resolutions at various aspect ratios, plus the CFG and steps they use. In the Qwen-Image Hugging Face repo, under the Scheduler folder, the config shows a flow match Euler discrete scheduler with exponential time shift, max shift 0.9, and base shift 0.5. The workflow's model sampling or a flow node uses a 3.10 shift. Should we swap it with a model sampling flux node using the scheduler's base and max shifts, stick with Oraflow at 3.10, or skip both? Let's test it out. First, I'll use the model sampling flux node with the scheduler's default values. I'll set CFG to 4, steps to 50 per the diffuser's implementation, switch the scheduler to beta, and keep the Euler sampler. I'll swap the Save Image node with a Preview Image node, fix the sieve for reliable testing, and add inverted commas to the negative prompt since they recommend it when it's empty. Now, let's enter a multilingual prompt for robust testing and run the workflow. In the terminal, you'll see the model loading. To monitor VRAM, I'll install NVITOP, run pip install NVITOP, then NVITOP, get this command from the description. VRAM usage peaks at almost 40 gigabytes. Here's our first image. Let's compare it to the prompt. We've got Takeshi's Ramen House and elegant brushstrokes, the now open sign on the lantern, and the menu on the chalkboard with correct items and prices. This is seriously impressive. I'll add another preview image node, rename this one Model Sampling Flux, and the next Model Sampling Oraflow. I'll keep everything the same, swap in the Model Sampling Oraflow node with its default 3.10 shift, and run it. The image is identical to the Model Sampling Flux version. Interesting. Let's add a third preview node, name it No Sampling, remove both sampling nodes, connect the model directly to the K-sampler, and run it. Same image again. Looks like we can safely ditch the model sampling Oraflow and Flux nodes without issues. Okay, let's test the workflow's default values. Add back the model sampling Oraflow node, set steps to 20, CFG to 2.5, scheduler to simple, and run it. Here's the image. Compared to the 50-step CFG4 version, it's different. The 20-step CFG 2.5 image misses the shop name's English positioning and brushstroke style, the now on the lantern, and some Chinese characters on the menu, though the English text is mostly correct. Let's bump steps to 30, tweaks the node names, and run again. The 30-step image leans toward the 50-step one, but still misses now on the lantern and has incorrect menu text. This tells us the diffuser's default CFG 4 and 50 steps work best for accurate results. For non-text rendering images, I think 30 steps with CFG 4 and a beta scheduler could do the trick. We'll stick with the diffuser's defaults for further testing. Let's try some prompts with different scenarios, starting with this one. Comparing the image to the prompt, we've got geometrical clothing, sharp shoulders, metallic lips, and makeup, all spot on. Now, a detailed prompt. This model has no token limits for prompts. The image nails the abandoned ballroom, marble pillars, clothing, and model description. Next one. Caramel highlighted hair, Bali rice field at golden hour, off-shoulder cotton dress. Check, check. Let's test the PPT prompt. I'll switch to the default landscape resolution from diffusers and run it. They got the heading and most bullet points right, plus elements like before, after images, and bottom text with minor errors. This could be a killer tool to visualize PPTs, spark design ideas, and refine them. Another PPT prompt for a fashion brand. Most text is correct with slight mistakes. A solid starting point. Now, an app design prompt. I'll adjust to a phone-friendly resolution. Again, most text is accurate with minor issues. Great inspiration for app design. Back to landscape for a website design prompt for a fashion brand. Text is mostly correct, but some errors crept in. Still, it's awesome for visualizing design ideas before diving in. Let's try an anime style prompt. Nails the style and character perfectly. Now Van Gogh's artistic style. Here's the generated image next to a reference, looking pretty spot on. The 3D render style. Wow, it's a bit realistic thanks to photorealistic in the prompt. This model follows prompts literally, so tweaks them if needed. Disney Pixar style. Kind of close, but not 100%. A brand logo. Decent. Could work for a skincare brand. Nature landscape. Pretty solid. A portrait with specific camera details. Looks great. That's all for testing the Qwen-Image text-to-image model. It's a huge upgrade from Flux, unmatched prompt adherence, higher resolutions, and killer text rendering. Overall, it's an awesome model, and I'm super excited for their upcoming image editing version. Want to support this channel? Use the link in the description to sign up for RunPod and use it as your main account. You'll get a random bonus credit of $5 to $500. That's all for this video. Hope you guys found it helpful. If you did, please like the video, subscribe for more videos and automatic installer scripts, and share your thoughts in the comments. This is Miro, and I'll see you in the next one.